Moving on to example 4. This is a compound inequality. Because we have it all in a single statement, we call it an AND inequality. Here's the awesome thing about AND inequalities. We have numbers on the outside, and they always have to be that way, because what we do is we solve the inside equation for x and do the work on both the right and the left side. It's the same as splitting these up into two separate equations. And I usually use that line because I don't do this very much, and it keeps me on track in this kind of unusual solving sequence. So I get 3x less than or equal to 4. Let's get that x all by itself. So what we get is negative 4/3 is less than or equal to x, which is less than or equal to positive 4/3. Now, if you think about this span on the number line, it makes sense. Our inequalities are facing the correct direction. If they were facing the other direction, let's say we forgot to switch them when we were multiplying or dividing by a negative, it wouldn't make sense. So always kind of take a look at that and make sure it makes sense with these compound inequalities. All right, so we are going from negative 4/3 to positive 4/3, and it does include those 2 points. So our interval looks like this. All right, on to example 5. Solve the inequality, express your answer in interval notation. Same idea, just clearing the fractions at you one more time. We're going to take this whole thing and multiply it by 3. Multiply it by 3. And see how easy it is to forget those constant multiplications. Solve it. Less than or equal to x, less than or equal to 13/2. And okay, does that make sense? Yeah, because 2 goes into 13 6.5 times. Yep, that makes sense. All right, for the set of cost and revenue expressions, find the break-even point and give the values of Q for which the revenue exceeds costs. This is really just inequality you have to solve, and you just have to pay attention to the words to figure out how to set up that inequality. Find the break-even point. Okay, that's where it's going to be equal. That tells us we have equal, and give the values of Q for which the revenue exceeds the cost. So depending on how we set it up, we want to show that costs are less than or equal to revenue. We could have set it up the other way. R is greater than or equal to cost. Same. So we're looking for where revenue exceeds cost is equal to the break-even point or exceeds costs. So let's plug in our functions. 8Q plus 150 less than or equal to 10Q. Let's solve this. Let's get rid of those variables first. Otherwise, I might just go in circles. All right, it looks like the final mathematical answer is Q has to be greater than or equal to 75. Okay. And I'm not sure what this is going to look like on the quiz, but they'll probably just have you fill in the blanks. Let's go ahead and write it in a sentence. Break even at the equals part at Q equals 75. So right at 75, the cost and the revenue are equal. That's your break-even point. You're not going to lose any money there. And costs are less than revenue from 75 to infinity. And we're done with that problem. As I was working this, I realized that you it's not in the assignment, but in the quiz, you've got a problem on a compound OR inequality. For example, 3x is less than 6, or say 2x is greater than or equal to, let's say, 12. So if you solve these two, you get the, and I'm going to skip some work here, just divide by 3, I get x is less than 2, or x is greater than or equal to 12 divided by 2 is 6. All right, that makes sense. These OR inequalities, they tend to point to the opposite directions. And I want you to see this. This is the only reason I'm showing you this is what the interval notation looks like. So x is less than 2. We go negative infinity to 2. And then we use this symbol, union. It just means and also x is going to be, sorry, I need a square bracket there. It's going to be, it'll go from 6, including 6, to positive infinity. Okay, there we go. All right. Hopefully you'll be able to tackle the practice and the quiz. I'll see you in class.